In order to calculate the equivalent series resistance, we'll have to use Ohm's law and the Kirchhoff voltage law. The way we're going to do this is very simple. We have V, we have I, and we have R1, R2, R3. So V is an input because it's the battery that we placed here. What we want to do is we want to, from these circuits, from the original circuit on the left, we want to calculate the values of I. Of course, we're not going to be able to calculate the value in terms of amps, amperes, because we don't have the value of the voltage, we don't have the value of resistance, so we will never know the actual value of the current. Our goal is to calculate I as a function of V, R1, R2, R3. In order to do that, the first thing we want to do is to give a name to the voltage across the three resistors. So because the resistors are called R1, R2, R3, we're going to call the voltage V1, V2, V3. The orientation of the arrow of the voltage is random. Of course, I know already what is the result, so I put the smart way to put this the orientation, but even if you place it upside down, you can still get the right results if you follow the Kirchhoff voltage rule. So anyway, just random orientation from the top, and that's it. So now, using Ohm's law, I can write the value of V1 as a function of I and R1, because V1 has to be equal to R1 multiplied by I. And for the same reason, V2 is equal to R2 multiplied by I, and V3 equal to R3 multiplied by I. Very simple. So now, if we use the Kirchhoff voltage law, like this, I can apply decide a certain random orientation. It's very easy to write that V has to be equal to V1 plus V2 plus V3. So now you can see that here we have all the elements, right? We define V as a function of V1, V2, V3, and V1, V2, V3 has been defined as a function of R1 and R2, R3, and I. So now if we replace V1, V2, V3 with the definition of V1, V2, V3 from these three equations, we get the V is equal to R1 multiplied by I, R2 multiplied by I, plus R3 multiplied by I. Now we can collect I, because this is, we have the sum of three terms, and all three terms have I. So if we collect I, we obtain R1 plus R2 plus R3. If we do this, very easy to calculate what is the value of the current as a function of V, R1, R2, R3. So the current I will have to be equal to V divided by R1 plus R2 plus R3. Now, what we're trying to do with this exercise was to find a value for the resistance R series that will give us the same current for the same voltage applied V. It's very easy to see from this very equation that the value that R series has to be to give you the same current I is equal to R1 plus R2 plus R3. So R series will be equal to R1 plus R2 plus R3.